a silent rock, moving on a path that defied all the familiar rules of our solar neighborhood. 3I Atlas drifted in from outside our solar system, likely from the Milky Way's thick disk. Tonight, as you drift off to sleep, we're heading deep into the quiet archives of astronomy, to a moment when a routine sky survey flagged something that shouldn't exist. A silent rock moving on a path that defied all the familiar rules of our solar neighborhood. Welcome to the story of 3I Atlas, the third known interstellar interloper. Recently released photographs reveal an object not only bending the rules of science, but also one that's traveling extremely fast. Roughly 58 kilometers per second relative to the Sun. At perihelion, the comet's speed peaked at 68 kilometers per second, with its curved path around the Sun being unique compared to previous interstellar visitors. Its high speed, which exceeds 200,000 kilometers per hour, means that it is not gravitationally bound to our Sun and will hopefully fly out of the solar system. Recent observations have noted an unusual non-gravitational acceleration, which may be due to the comet outgassing, though some have speculated other causes. The first glimpse, a dot defying gravity. The Atlas telescope in Hawaii performs its nightly routine, a slow mechanical sweep of the sky. It's looking for near-Earth objects, things that orbit our Sun, following the predictable curves of celestial mechanics. On this particular night, it logs a faint speck, just another dot in a sea of dots. But this one was moving just a little too fast. The velocity was the first clue, a number that, when fed into the orbital calculations, didn't quite fit. The path wasn't a neat ellipse around our Sun. It was more like a straight line gently curved by gravity's touch. This is where the slow dawning realization begins for the astronomers analyzing the data. This velocity can't be explained by a solar orbit. The numbers suggest something more profound, something that had been theorized but never before caught in the act. A trajectory that originated from interstellar space. And so comes the moment of classification, a seemingly bureaucratic step that carries immense weight. They assign it the prefix I for interstellar. 3I Atlas. The 3 denotes it as the third such object ever confirmed. The I is its passport stamp, a single letter that separates it from every other asteroid and comet we've ever known. It's a label that transforms a dot of light into a permanent traveler, tracing the path backwards, a journey of billions of years. Once you know it's from elsewhere, the next question is the most natural one. Where did it come from? This leads to the mathematical challenge of retracing a path with no known starting point. You have its current velocity and direction. The task is to rewind the tape, to account for the gravitational pulls of every star, every planet, every significant mass it might have encountered on its way to us. It's a cosmic backtracking problem of almost absurd complexity. Here's where we encounter a key concept: hyperbolic excess velocity. This is the speed an object has left over after it has escaped a star's gravity. Think of it like a rocket that has broken free of Earth's pull. It still carries that initial escape velocity as it coasts through space. For 3I Atlas, its speed was too high to have been bound by our Sun's gravity alone. It arrived with a built-in velocity from a previous stellar system. Mainstream fact moment. By projecting its path backwards against the motions of nearby stars, astronomers can make an educated guess about its origin point. The likely candidates point towards the general vicinity of the Carina or Columba constellations. Not to a specific star, but to a region of space, a neighborhood of stars from which it could have been ejected millions or billions of years ago. And that's the next layer of the gentle mystery, the immense time scale. The journey likely lasted hundreds of millions, perhaps even billions of years. It spent ages drifting through the silent conditions of interstellar space, the cold, empty void between stars, a realm of near-total blackness, where the distances are so vast that stars are merely faint points of light, unchanging for millennia at a time. Now, a quirky tidbit about our visitor: its tumble and lack of comet-like activity. When comets from our own solar system approach the sun, they heat up and release gas and dust, forming a bright coma and often a tail. 3I Atlas did none of that. It remained a silent, dark rock. This suggests it's more asteroid than comet, a rocky or metallic body that formed in the inner, hotter region of its home star system, where ices couldn't survive. Its silence is a clue to its origin story. So you walk along the rows of data, from its detection to its classification to the theoretical map of its long journey. It's a path traced not in light, but in gravity and velocity, a ghostly route through the galaxy that we can only infer. And yet, the inference is powerful. It tells us this rock has seen things we can only imagine. It has sailed past unknown worlds, through nebulae we haven't named, all in utter silence. The Great Filter. Why it arrived alone. This leads to the next layer of the gentle mystery, a quiet puzzle that astronomers call the Great Filter. Why did it arrive alone? Our galaxy is teeming with stars, many of which likely have their own planetary systems, their own collections of asteroids and comets. The math suggests that ejections like this should be relatively common events. So where are all the other travelers? Why is the detection of an object like 3I Atlas such a rare and momentous occasion? This is where we enter a scientific debate, a quiet argument that plays out in academic papers and conference halls. It centers on the fundamental fragility of most small bodies in space versus the surprising durability of a select few. The vast majority of objects flung from a star system are likely to be icy, comet-like bodies. They're fragile, porous, and vulnerable. They are the snowballs of the cosmos. And the interstellar medium is not a perfect vacuum. It's a sparse sea of gas and dust particles. Over a journey lasting hundreds of millions of years, a fragile, icy body would be slowly eroded, sandblasted into nothingness by the gentle but relentless friction of deep space. It's a filter that only the toughest can pass through. This is the gentle mystery of what gets destroyed on such a long journey. The silence of space is not a protective blanket. It's a testing ground. A rocky or metallic asteroid, like 3I Atlas appears to be, is far more resilient. It can withstand the micrometeorite impacts and the subtle abrasion that would pulverize a comet. So its solitary nature might not be a sign of rarity, but a clue to its composition. It survived because it was made of sterner stuff. It passed through the Great Filter. But there's another, equally plausible possibility. The idea that many more have passed by, too faint for our telescopes to see. Our surveys are good, but they are not all-seeing. They are biased towards larger, brighter objects that come relatively close to Earth. A smaller interstellar rock, or one on a more distant trajectory, would slip through our nets completely unnoticed. So its apparent solitude might be an illusion born of our own technological limitations. The galaxy could be full of such silent travelers, a constant, unseen traffic of rocks drifting between the stars. This brings us to a rather beautiful, humbling idea. the concept of our solar system as a temporary harbor for a cosmic wanderer. For a brief moment, measured in mere months, this object was caught in the gravitational well of our sun. It became, temporarily, a part of our system. We gave it a name, we tracked its path, we claimed it for a moment. But its trajectory was always hyperbolic, always an escape route. It was never going to stay. It used our star's gravity as a slingshot, a way to boost its speed slightly before continuing on its infinite journey. We were just a rest stop on a road that has no end. A message in the silence. What the rock carries. So, if this rock is a messenger, what is the message it carries? It's not inscribed with symbols or encoded with data in a way we can decipher. Its message is written in its very being, in the information encoded in its composition. If we could somehow sample it, we would be holding a physical snapshot of another star system. We would learn about the elements present there, the conditions under which it formed, the building blocks of a world we will never see. Its silence is its story. The absence of a tale, its lack of cometary activity, is itself a profound piece of data. It tells us that this object formed in a hot environment close to its parent star, where ices could not condense. It's a rocky relic from the inner sanctum of an alien solar system. Its silence speaks volumes about its origin. The profound simplicity of its message is this: that solar systems are not entirely isolated. For a long time, we thought of our solar system as a closed ecosystem, an island universe. But objects like 3I Atlas prove that the walls between star systems are porous. Material can and does travel between them. The building blocks of planets, perhaps even the precursors to life, might be exchanged on these incredible journeys. We are not an island. We are part of an archipelago. It suggests that the ingredients for life, or at least the complex chemistry that leads to it, could be shared across the vast distances between stars. Thanks for watching. You can check out more great documentaries and films to help you sleep in our playlist on this page.